Here's a physics question for you, and I'm going to try not to hit myself. So I have this mass moving around in a circle over my head, and it's connected to this string, to this weight. So what happens is that the tension in the string is constant. Now, the question is, suppose that I notice that it doesn't swing in a horizontal circle, right? The string's tilted down. What if I make the string shorter? What will happen to the angle that the string swings at? Let's just do it, and then I'm going to show you why. So here, the string's shorter. It's going to be easier to swing because I'm not going to hit myself. And we're going to go, boom. Oops, I did hit myself. I'm going to keep doing it. I'm not stopping. We're going forward. Okay. String. It's not easy, you know. I'm trying to get it in a circle. Okay, there we go. So the angle doesn't change with the length of the string. And let me show you why. Here is my mass hanging down, and here's my mass moving in a circle, in a horizontal circle at some angle theta. Well, if I look at the forces on this one, it's at equilibrium because it's just hanging there, so the tension in the string is equal to the weight of this mass. That's the same string tension up here. But if I draw the force diagram for this one, I have the tension at an angle, and it has to support that mass m2. So this one doesn't accelerate in the y direction, so t sine theta is the y component of that, minus m2g is 0. But that doesn't change as I make the string longer, right? Because that depends on this mass down here. And g doesn't change, and m2 doesn't change, so theta can't change. So as you make the string longer, it's still at the same angle. That same tension has to have the same vertical component to support the thing. Now, some things do change as you make the string longer, because the acceleration towards the center depends on the velocity and the radius. And as I make this longer, the radius of the circular motion does increase. So things do change, just not the angle.